iteration it was this position. So now in next iteration, what will be the parent node which will be checked for its proper position, and no, position this. So in this iteration 10 will be the parent node which will be checked for proper positioning. Now which will be checked for the mean heap property, whether it satisfies to be the mean heap or not. Now it has two children, 17 and 4. Now 10 is less than this child 17, but 10 is not 10 is greater than this child. So 4 and 10, these parent and child will be swapped with each other. So the tree changes and the tree is modified to 7. Now 4 will come to place of 10. So here it is 4 and 1, and this is 17. Now 10 will come at the place of previous position of 4. So it will be 10, and here it is no other nodes will be changed. Now so this has been changed. 10 has come to this position. So 19, 37, then 42, 23, 33, then 27, then 16, 11. Now what is the new child? It is 10. Now 10 will be checked for further downward movement. So 10 has children 42 and 23, which are both are higher than its parents. So we will not go for we will not consider further downward movement. So our iteration, so we will stop further downward movement, and at the now the what was the parent at this iteration? That is this position, and this is not a root node. So we will go for the next iteration. So we will go for the next iteration 8. So the last modified 3 will be used in this iteration, which is 7, 4, 1, 17, 10, 25, 5, then 19, 37, 42, 23, 33, 27, 16, 11. So in previous iteration it was the parent node. So in next iteration the previous parent node will be checked for proper positioning. That is, this position 7, this position will be checked for proper positioning. Now 7 is compared with its children 4 and 1. Both are less than 7, but among these two children, one has the lower value than other child. So we will swap the position between 7 and 1. So we will swap the position. So 1 will go. So the tree changes, and at the position of 7, 1 comes, and 7 goes to the position of 1. So 7 comes here. All other nodes become unchanged. So it is now, this is the current position of the child node, which will be checked for further downward movement, but all other nodes will be copied as it is. 19, 37, 42, 23, 33, 27, 16 and 11. Now this 7 will be checked for further downward movement. So it will be compared with its children, which is 25 and 5. Though 25 is greater than 7, but 5 is less than 7. So 7 cannot be parent of this child. So this parent and child positions values swapped with each other. So now the tree changes. So we obtain 1, 4, 5. That 5 will come to the position of 7, then 17, 10, and at the place of 5, 7 will go. So 25, then 7. Now this is the new child position, which is 7, 19, 37, then 42, 23, 33, 27 and 16, 11. Now 17 will be checked for further downward movement. So 7 will be compared with the children 16 and 11. Both have higher value. Both children have higher value than the parent. So we will not do for further tree modification or further changing in the tree. So we will stop this further, stop considering the further downward movement. And in this iteration, the parent node was this, position was this. That is, this the parent node is a root node. So we will not go for the further iteration. So this tree becomes the property of a heap, mean heap. So this tree satisfies to be a mean heap, because we will check in mean heap the subtree, the parent node of every subtree, the root node of every subtree has lower value than all of its children. Now one is have lower value than its children 4, 5. 4 has lower value than its children 17 and 10. 5 has lower value than its children 25 and 7. Now 17 has lower value than its children 19 and 37. 10 has lower value than its children 42 and 23. 25 has lower value than 33 and 27. 7 has lower value 16 and 11. So all subtree in this tree satisfies the property of a mean heap. So initially what was the tree structure? So if I go for initial, so this was the initial binary tree. After converting it to mean heap, so what we obtain after converting to mean heap, we obtain the mean heap as 1, 4, 5, 17, 10, 25, 7, 19, 37, 42, 23, 33, 27, 16, 11. So here we have seen, we have shown how this binary tree is converted to mean heap by this procedure. Okay, thanks.